Today, let's discuss an interesting topic, integer caching in Java. Let's understand these two examples before moving further. When you compare integer value 10 to 10, the result is true, but when you compare 128 to 128, the result is false. Confused? Let's dig deeper. In the shown examples, A and B are two integer objects. They are not one of the 8 primitive types in Java. Integer is actually a wrapper class for the primitive type int. So apart from the 8 types mentioned, all other types are objects, which store references and not the data itself. Let's see the memory distribution of second example in the JVM. Two local variables, C and D, are created on the stack, and two memory areas are allocated on the heap, both storing the value 128. The reference of variable C points to the address of the first 128. The reference of variable D points to the address of the second 128. Obviously, the references of C and D are not equal, since comparing two integer objects with double equals checks if the references are equal. So why does the first example return true? Shouldn't it return false as well? The answer lies in integer caching. When defining objects C and D, Java automatically calls integer.value_of to wrap the number into an object. And if the number is within the range of 128 to 127, inclusive, it is directly retrieved from the integer cache. In Java, the integer class maintains a cache of frequently used integer values within the range of 128 to 127. When an integer value within this range is auto-boxed or retrieved using integer.value_of, Java returns a reference to the cached integer object instead of creating a new one, since the first example is within the 128 to 127 range, so the references of A and B point to the same address, but values in second example exceeds the 128 to 127 range. So the references of C and D point to two different addresses. That's why the results are different in both the cases. Now the question comes, why does the integer class have this cache? This caching mechanism helps conserve memory by reusing integer objects for commonly used integer values, reducing the number of objects created, and promoting better memory utilization. Additionally, it can improve performance by reducing the overhead associated with object creation and garbage collection. It's important to note that integer caching is specific to the integer class in Java and does not apply to other numeric wrapper classes like long, short, byte, etc. Furthermore, integer caching behavior may vary between different Java implementations or versions, so it's advisable not to rely heavily on this behavior for critical application logic. But what if you want C and D to return true when compared? Answer is, call the equals method. Hope you found this topic interesting and learned something new today. Don't forget to hit the subscribe button and give us a like to show your appreciation. Stay tuned for part 2 of the video.